if they can't make it. So thanks for joining. We're going to do the first 15 minutes on polynomials. Next 15 minutes we'll take questions. 15 minutes on completing the square. Another 15 minutes on questions. And I am April Barton. I may or may not be your actual teacher. And I just realized I spelled my contact information incorrectly. Let's fix that. I'm one of the 3 math teachers, so the 2 of us have been doing these live sessions. And when you have questions, you can either chat your math teacher, or you can email them, or you can email me with any questions you have. While we're going through, Hunter, I am going to mute you. Just sometimes there's background noise, so when you're ready for a question, unmute, and then when you're ready to listen again, mute again so that we don't have background noise. So just a small reminder before we talk about polynomials is to not forget that after you complete your assignments, then you still need to take a final exam. The course doesn't actually go onto your transcript, your official school log of all the classes you've completed, until you've passed the final with a 60% or higher. So any questions about finals you have before we talk about polynomials?
No.
Okay.
No.
Perfect. So Renata, I'm going to ask you the same thing. If you'll keep your microphone muted until you're ready to talk, otherwise we'll have my background noise and your background noise. So we've got to keep it muted as much as possible. Okay.
Should I just, how do I mean to just push done speaking?
Yeah, when you're speaking, unmute yourself so that you can ask the question, but otherwise we have so much background noise if everyone's muted at the same time.
Okay, I'm muted now.
Okay. But feel free, unmute yourself whenever you want and ask an actual question. You can interrupt at any time. We're just trying to eliminate some of the background noise. Okay, so polynomials. This is seen in Algebra 1 and Algebra 2. You should be able to see my screen where I talk about the different parts. So a polynomial is any grouping of numbers and letters. As long as you have numbers and letters all grouped together, this is called a polynomial. So there's different parts to this where you need to know what each part means so that when you read about it or hear about it, you'll know, well, this is what they're talking about. So the first thing is a term. And a term is each entire piece at once. 5x cubed is one entire term. Negative 2x is one entire term. 4 is one entire term. So the term is just one entire group. That's considered a term. The coefficients get a little more specific. The coefficients are any number in front of a variable. 5 is a coefficient because it's in front of x cubed. So what's our other coefficient for this polynomial? What other number is a coefficient?
Negative 2x.
Close. The x is not considered the coefficient. We need the number in front of the x, but the coefficient is specifically only the number.
Yeah, my bad. That was the entire term.
Yep. Good. The variable is the letter itself. Most of the time you'll see x's. You can technically use any letter. I stick with x most of the time in the courses, and most of the time it's x, just because it's one of the nicer variables to use. Sometimes like when you get A's and stuff, they look like 9s. So usually you'll see the letter x. And then constant is when you have a number that doesn't have any variable with it. 4 is not a coefficient. We didn't include it on that list because it's a constant. It's all by itself. And then just a random term that sometimes I'll throw out there is math operations. So for the polynomials, those would be the adding or the subtracting. You're minusing 2x, so minus is a math operation, or you're adding the 4, so adding is a math operation. So also when you're working with polynomials, sometimes you'll need to name them. We know the parts now. When you're naming them, there are always two names. Like I could call something a linear monomial or a linear binomial or a quadratic monomial. All of these, you have to pick one from the degree column, pick one from the number of terms column. So the degree column, what is degree? Degree is the highest exponent of your polynomial.
Cubic, that'd be 3 to the power of 3. Quadratic is to the power of 2. And is single. So 4x squared, and 4x cubed, correct?
Mm-hmm. Yep. Or any coefficient. And so linear, it kind of cut out a little bit. Technically it is to the first, but they're never going to write that degree in. 4x technically has a degree of 1, but it's one of those invisible numbers. We see those a lot in math where they're like, everyone knows that there's a 1 there. We don't need to write it. But that's not always the case. Hi Dylan, thanks for joining. We are currently talking about polynomials and how to name them. So we've covered degrees. Linear is when there's a degree of 1. Quadratic is a degree of 2. The degree is determined by the exponent itself. We don't actually care what number is in front for the degree. Any number can be there as long as you identify the exponent. So the number of terms is how many pieces in the polynomial. 2x is considered one term. So monomial is one term, binomial is 2 terms, and trinomial is 3. So let's name a polynomial. I'm going to write one up and then we'll name it. So we have to pick one name from the degree column and one name from the number of terms column.
Currently for the negative 5x or for the 2x?
This whole thing is one polynomial. So we have to pick the name. So the highest exponent is the 3. Even though there's 2 exponents here, we only care about the highest one for naming. So if the highest exponent is 3, what name do we use when it's a 3 for the highest exponent?
Do we use trinomial?
Trinomial is when there's 3 terms. You're right that trinomial involves 3, but 3 terms is determined by each grouping. So terms-wise, there's 2 terms, but a degree of 3.
So it'd be binomial.
So binomial from the number of terms, that's the second name. We still need a name from the degree column.
Cubic.
Good. So the entire thing is a cubic binomial. And Dylan, if you ever want to answer a question, you can unmute your microphone to answer questions, or you can type into the chat box. I try and monitor that as much as possible. So let's try one more. Okay. So this is the entire polynomial, 7x squared. What name do we give that?
That is a quadratic binomial.
Did you say binomial?
Yes.
Okay. So even though the degree is 2, so quadratic is correct because that was the degree. We had a degree of 2, gives us quadratic. This is one term. Each term is separated by those math operations. So we know there's a new term if we say plus something or minus something. So if there's only one term, what should we use?
Mononomial. Okay.
Monomial. Yep. Good. So let's practice just one more. Running out of room. I might actually write it a little up and to the right. So let's say we have x squared minus 3x plus 5. What would we name that?
I don't know how to pronounce it. Is it chondro?
Quadratic.
Terminal?
Quadratic trinomial. Very good. Okay, and we had a couple people join. Sorry, I can't spell and try to actually say something else at the time. Same time. Okay. So quadratic because degree of 2, trinomial because 3 terms. Thanks for everyone who joined just now. See Kim and Latoya. We were talking about naming polynomials by the degree and number of terms. When you pick the degree, that's the highest exponent. And when you pick the number of terms, that's each grouping in the polynomial. So you have to pick one from each column to name it. So something else you might be asked to do with polynomials is to add or subtract them. So a lot of this notation looks really weird. This f of x notation is just to give it a specific name. This is called function f. Function is a fancy math term for any type of problem we're working with. Polynomials is one type of function, but maybe you have a radical or a rational. So function is just a general group name for every math equation you could work with. And so this one is specifically function f. The parenthesis x kind of looks like multiply. Most of the time parentheses mean multiply. In this case, it's just saying the variable we're using is x. So it's function f using the variable x. So I know the left side looks kind of tricky, but it's really just to give it a name. That way we know this thing is saying use function f. And then polynomial g of x is just to give it a second name, or a different name. We have one function f, one function g, and we're really just looking at the symbol between them. If there's a plus sign, it's just telling us to add these together. So we start with f, 4x squared minus 7x, and we add g, 2x squared plus 3x minus 4. And when you add polynomials together, you look for like terms. When you're adding like terms are determined by that variable and exponent. So 4x squared, what's the other like term to 4x squared?
3x.
2x squared.
Okay, so we had two different answers. Both had the same variable, but it's also got to have the same exponent. So 2x squared is the like term to 4x squared because they have x squared. The 3x, what would the like term to the 3x be?
7x.
The negative 7x. So once you've identified like terms, we combine them together. And when you combine them together, we're literally just adding the coefficients, the numbers in front. 4 plus 2 is 6, and then we leave the x squared how it is. That like term just stays the same. Negative 7 plus 3 is negative 4x. And if you're ever unsure, I know it's sometimes hard with the positives and negatives, then just plug it into a calculator. You can use online calculators, you can download one on your cell phone, you can buy one, but just type in the negative 7 plus 3 and have it pop out the answer for you. And then -4 at the end didn't have a like term, so we just leave it at the end. And my whiteboard's being a little bit weird, I think because I went over to the calculator. So let me refresh it. So we're out of the time for polynomials. If we have time, I had a subtraction problem set up. We can go back to it. But let's get to the question time, since the 15 minutes for question time is here. So what questions do you have from your courses?
See, going back to the problem that we had, 4x squared plus 16x, we were left with 2 times x, parentheses, x plus 2 times 2, and parentheses, equals 4x, parentheses, x plus 1, and parentheses.
I'm going to go just to what we had written down. So we talked briefly about this problem before we officially started the class. So the final answer for this problem is the one down at the bottom. That is the greatest common factor.
Oh.
Yep. So just to explain this process for the people who weren't here when we talked about it, when you're doing a greatest common factor, this is backwards distribution. When you distribute a number into a binomial, when you multiply it in, you end up multiplying twice. You do 2x times the 3x, and you do 2x times the -5. And then you get your final answer, 6x squared minus 10x. So greatest common factor is doing that process backwards. You start with a polynomial, and you want to go back to where there was something in front of a set of parentheses. So when you go through this kind of problem, our original was this 4x squared plus 16x. I'm going to go ahead and erase this so we can talk about it a little bit better. So to break this down, you do something called a factor tree. You want to find any numbers that multiply to be 4 except 1. We don't care if 1 multiplies to be it, but are there any numbers that multiply to be 4? What 2 numbers multiply to be 4?
2x times 3x.
Close. 2x times 2x, and really we're focusing on the 4 itself, because the 2x times 3x was a different problem. That was my explanation for why we do this in the first place.
So with the 4, we break it down to 2 times 2.
Yes, yep.
Times x times x.
And then we also break down the x squared, which means there's 2 x's. So now we have to do the same thing to the 16. How can we break down 16?
That would be, now I tried to do it before. So if we're going to break it down the same factors before, that would be,
8 times 8.
Okay, you can use 8, but 8 plus 8 is 16. We want it to multiply.
Oh, okay, okay.
So 8 times what?
2. 8
2.
times 2.
Yep. Now someone else might have said, well, 4 times 4 works. That's right. You can do either setup. In the end, you'll still get the correct answer. If we do 8 times 2, now we have to break down 8. What 2 numbers can multiply to be 8?
2 and 2, 4 and 4.
Remember, we're trying to do just 2 numbers that multiply to be 8.
4 times 2.
4 times 2, good. So we don't want them to add to be 8, we want them to multiply. And we only cared about the 8 at that moment. So now we only care about this 4, and we already know, because we did it once, what 2 numbers multiply to be 4.
2.
2 times 2. So since the 8 split off to the 4 and 2, we don't care about it anymore. And since the 4 split off to the 2 and 2, we don't care about that anymore. And Latoya, I'm going to keep you muted until you actually answer a question. We just end up, I already have enough background noise here, so if we keep adding in background noise. So I do try and keep you guys muted until we're actually answering questions. So the 4x squared, we're going to bring down, we're going to clean it up a little bit. The plus sign we're going to bring down. And then we're only going to bring down the ends. We call it a factor tree, so I'll call these branches. The ends of the branches is all we care about. So like the 16 got broken down, we don't care about that anymore.
Hi, is this Cynthia?
And then we also bring down the variable.
How are you?
So now we're looking for in each set. We have the stuff before the plus sign and the stuff after the plus sign. We want common things. So what's in common between the blue and the pink?
X plus 2 or times 2.
Okay, we have an X, that's in common. We have a 2, that's in common. One more thing.
We have the 2 in front and also the 2 in front.
We have another 2. Okay. So that common stuff, that's called the greatest common factor. That's why we use the word common, because it's in common. So in front, this example I was doing at the very beginning to show this greatest common factor number in front, when you distribute, it ends up getting used twice. So when we go backwards, it's like we're taking the 2 things and merging them into 1. We don't write 2 times 2 times x times 2 times 2 times x. We only use that common stuff one time. Everything that's not in common goes inside the parentheses. And then we don't leave stuff like that. If we can multiply it together, we do. So 4x times x plus 4 is your final answer for that greatest common factor problem. So any other questions about greatest common factor or about any other topics you have from your individual courses?
Yeah, I've got a question on multiplying matrices.
Okay.
Okay, the whole thing's still kind of confusing to me.
Okay, so matrices is in Algebra 2. When you multiply matrices, there's a couple of rules we need to know. So a matrix is a way to organize a whole bunch of information. If you have a lot of data that's related to each other, they tried to simplify it by putting it in a matrix. And they're used in like video game programming a lot and computer programming. But we need to know how to name them first. So we name them by their rows and their columns. So this matrix would be 2 by 1 because there were 2 rows, 1 column. The second matrix, what would we call this one? How many rows and how many columns?
2 by 2.
2 by 2. Now this is important for multiplying. Sorry, it's hard to write with the mouse. That was supposed to be the word column. So when we multiply numbers, we can multiply in any order. If I did 5 times 8, that's 40. If I do 8 times 5, still 40. Doesn't matter if we switch the order, get the same answer. It's not true with matrices. With matrices, this middle, so for multiplying the 2 by 1 times the 2 by 2, if these middle 2 numbers match, you can multiply. If they don't match, you just can't multiply. It's not possible. Let's say we switch that order. And I put the 2 by 2 first. And the 2 by 1 second. Now do our middle two numbers match?
Yes, 2 times 2.
Yes, they do. That means we can now multiply these matrices. We're good to go. The other interesting thing about matrices is the ones from the very start and the very end. If we can multiply, that tells us how big our answer will be. The answer matrix will be a 2 by 1 matrix. So we have 2 row spaces to fill and 1 column to fill. So basically we're going to be finding 2 answers. So when you actually do the multiplication, it's kind of a weird process. You just kind of have to memorize. It's hard to explain why we do it this way. But you do the row times the column, and you do the first number in the first row times the first number in the column. So 4 times 2. And then that is 8. That is correct, but that's not the final answer yet, because we add the second number in the row to the second number in the column. So add -1 times 3. So what do we get when we simplify that part?
So, we've got, did Marley talk to you about orientation?
How do I add the,
So school starts Monday.
Sorry, we had 2 people answering. Go ahead, Renata, since you're still unmuted.
First day.
I was just wondering, because I got confused on when you said add -1 to the 4. So, because 4 plus 1 is 5. So I don't understand how to do the negative.
Okay. So the negatives,
I have openings today.
first of all, we have to know which ones we're going to actually multiply by. So the 4 and the -1 in this process never actually have anything to do with each other. It's just a really weird process. This 4 goes with this 2. This -1 goes with this 3. So the 4 and the 2 went together. -1 and the 3 went together. When you're multiplying, a -1 times a positive is going to come out as a negative number. So multiplying a positive times a positive is still positive. A negative times a negative is also a positive. So when you have 2 of the same, it comes out positive. And if you have 2 different, if you have a negative times a positive, it comes out negative.
Okay. Did you fill out an enrollment packet with Marley?
So the -1 times the 3 comes out as a -3, because a negative and a positive is negative.
I'm going to send to you.
And then we add those together. What do we get from 8 plus -3?
So we're looking at 12.
That would be 8 plus a positive number. If we're adding a negative, let me draw this out really quick.
I said 12. I mean 11.
Okay, that would be if the 3 was positive. If we're at an 8 and we're adding a -3, negative means go left on the number line. So we actually end up at a 5 because it was a negative number. If it had been 8 plus 3, then it would have been the 11.
So we write it down as 8 plus -3 equals -5.
Positive 5. We would have to keep going. It only said count 3 spaces. We had the space from 8 to 7, the space from 6 to 7. We would have to keep counting a whole lot more spaces to get to the negative actual numbers.
Okay. I think I'm understanding better now.
Good. Okay. So then we still need one more answer for our answer matrix. Now we do the second row times the same column. So 2, 0 times the 2, 3, and it's still first times first plus second times second. 2 times 2 plus 0 times 0. And once you have that set up, now we just do the sorry. If I make a mistake, let me know. It happens a lot. That should have been 0 times 3. Now that we have it written correctly, what does that come out to be?
Wouldn't it be 4?
Yes, the final answer would be 4. 2 times 2 is 4, 0 times 3 is 0, and 4 plus 0 is 4. So a lot of extra work on the side. The actual answer is the matrix 5, 4. So does that clear up your question on multiplying matrices, Dylan?
Yeah, that helps out.
Okay. So we'll have more question time after we talk about completing the square. Think about what questions you might want to do for the last 15 minutes. Okay. So completing the square is a process that involves solving quadratic formulas. When we solve equations, it's a pretty straightforward process. We do opposites. If you have x plus 5 equals 7, you minus 5 from 7 and get your answer. When you solve quadratics, it gets a lot more complicated. Having that squared makes the process completely longer. Just a lot more steps, a lot more options of how to solve. So completing the square is one way to solve when you have an actual equation that involves a quadratic. One thing we need to be able to do before we can solve is to make a perfect square trinomial. We need to figure out a number to add at the end so that we could factor this as a perfect square trinomial.
What
So
about?
oh, sorry, go ahead.
Oh no, I'm sorry, I didn't mean to interrupt. I was saying, what about 4? Can 4 fit into there?
So 4 is actually going to be part of the process, but it won't be the final answer. The way to find this number is the same way every time. We take the coefficient in front of x, not in front of x squared, in front of x. We always divide that by 2. And then we square that, and that'll tell us this last number that we want to add. So we do the division part first. This is where our 4 comes up. Negative 8 divided by 2 is the negative 4. And then when we square that, that means multiply negative 4 times negative 4. So what will that come out to be?
Are we doing 4 times 4 and the negative times the negative is a positive? That would be 16.
Very good, positive 16. So that's our number to add to make this what's called a perfect square trinomial. So we need to know how to do that process to then actually solve by completing the square. Our goal is to actually figure out the answer for x. And with a quadratic, there's normally 2 different answers. We're going to have x equals 1 number, x equals a second number. So to do the whole entire process now, we have to remember the process we saw on the previous page, but now we're going to go through the entire steps of solving this entire thing. So the first step is to get all the variables on the left and all the numbers on the right. All the numbers on the right. So when we look at an equation, the left side is everything to the left of the equal sign. Right side is to everything to the right of the equal sign. What's wrong on the left side? What do we need to move because it's not a variable on the left?
Negative 5.
Good, the negative 5. And when we work with equations, we move that by doing the opposite. Opposite of minusing 5 is to add 5. And I'm going to leave this blank space on purpose. Normally we kind of smush it together. I want the blank space there. We do the actual addition, 40 plus 5 to get 45. And the negative 5 plus 5 canceled because that's 0. A negative 5 plus 5 is 0, but we don't have to write it anymore. So now we have to do that process we learned on the previous page. We want to find the number to add. And it's not just any number, it's that specific number to make it a perfect square trinomial. One thing that's different though is this number we're going to find to add, it affects our equation. When we do something to an equation, we have to do it to both sides. So we pick the number based off the left side, but we add it to both sides. So now we go through that entire process. We wanted the number in front of x. So what number is in front of the x?
2.
We're going to divide by 2. That's part of the process. We want the number, the coefficient. There's an exponent that's a 2. What's the coefficient in front of the x?
And 6.
Good. The 6 is the coefficient. The 2 is an exponent. The 6 is the number we want. It's always that number in front of the x. And then we always divide that by 2. This middle process, this step 2, is something you kind of have to have memorized. You need to know, I need to divide by 2, then square it. So we do the division. 6 divided by 2 is 3. We square it, which means do 3 times 3. A common thing I see is people do 3 times 2. Our mind just wants the 2 numbers that we already see to be what we're working with, but it actually means use 3 2 times. So now we add this number to both sides. So on the right side, we actually do the addition.
So when you actually do the addition on that side, come out to 54.
Correct. On the left side, we need to factor now. So earlier we talked about greatest common factor. That's only one type of factoring. So greatest common factor came from doing backwards distribution. This kind of factoring is going to be backwards FOIL. We want our answer to end up as 2 parentheses. So when there's this trinomial, the 3 terms, and it starts with an x squared. The x squared really means there's 2 of them. It's going to be split up into each parenthesis. Then we have to figure out, well, what number goes at the end? That's determined by both numbers we see here. The pattern is we want to find 2 numbers that multiply to be this last number 9 and also add to be 6. We need 2 numbers that multiply to be 9 and also those same 2 numbers have to also add to be the 6. So what 2 numbers would that be?
Would it be 5?
You could do 5 plus 1 to get 6, but 5 doesn't multiply to anything to get 9. I usually think of the multiplication part first. What are 2 numbers that multiply to be 9?
3.
3 times 3. So if those numbers also add to be 6, those are the correct 2 numbers. And in this case, we're done. We didn't have to do any other guesses. Another possible guess would have been 9 times 1, which equals 9, but then if we went to do 9 plus 1, that equals 10 instead of the 6 we want. So the 3's are our correct set of numbers. So each parenthesis gets a plus 3. So the reason we picked that 9 in the first place, the reason we went through that whole weird process and got a 9 is because now we notice these match. x plus 3 and x plus 3, that's the exact same thing. And that's how we know we're doing this correctly, is because they match. So when you have two of the same thing, we can simplify this and group it together and say this is x plus 3 squared. So we factored, now we write as a, this is called a perfect square, that's squared, perfect square binomial. And the mathematicians who thought of this were pretty clever. Like, seeing the process is hard enough, but someone had to go through and figure out, I can do this. They had to see it kind of in a new, different way to be able to figure out, I can even do this at all. Sorry again, it's hard to write with a mouse, so some of my words are not the best. So the reason we want to do that is because we can do the opposite of squared. So we have our common opposites. The one you see lots and lots is addition is opposite of subtraction. Multiplication is opposite of division. Does anyone know the opposite of squaring something?
Okay, so let's say they don't have
dividing the result by half.
Okay, that would be if you multiply by 2. Dividing by 2 is the opposite of multiplying by 2. And that's a common thing. We want it to be, it's kind of involving multiplication. It's kind of involving 2. But there's one specific math operation that is actually considered the exact opposite of squaring. Oh. So subtracting is the opposite. Someone in the chat box is saying subtracting. That's the opposite of addition. Opposite of squaring is square rooting.
Okay, I guess we'll find out.
So it's a weird new opposite that we don't see as much. It comes up the more higher up you go in math. You'll see it more in Algebra 2, but you only see it occasionally in the Algebra 1 courses. Squared and square root actually cancel each other out to leave just the x plus 3. So how are we going to square root the 54?
Divide it.
It's a kind of form of division, but, and I'm gonna, last time when I went to the other page on the calculator, it didn't work very well. Basically, our only way to square root it is to use a calculator. Square root of 54 is, you're trying to find specifically a number you could divide into 54 where you get the same number as an answer. So like, I'm gonna do a little side work again. If I said square root of 36, 36 divided by 6 gives you an answer of 6, or 6 times 6 equals 36. You get that matching number again. So the square root of 36 is 6. That's the only number that can multiply by itself to make a 36. 54 is a little more complicated because it doesn't have an exact number. It has a weird decimal. So you would want to go to your calculator. Oh, most of the time it's this little check mark symbol. So if you do 54 and take the square root, you get a weird long decimal. So that was 7.3. There's one more weird thing with solving quadratics. Completing the square is kind of a long process. If you have to do completing the square, you may want to watch the video a couple of times or look up more YouTube videos and hear someone else explain it. It's good to hear a long, complicated process like this multiple times in multiple different ways, because it's just gonna, you're probably like, I have no idea what's going on. That's normal. Most people feel that way. Got to see it multiple times before you're like, okay, I get this piece now, and I get this piece now. So the weird part of square rooting when you're working with an equation is there's actually two possible answers, a positive version and a negative version. So you'll start seeing this symbol when you're completing the square or when you're doing quadratic formula called the plus minus symbol. If we go back to our 36 problem, 6 times 6 equals 36, but also negative 6 times negative 6 equals that positive 36. So really we have a positive 6 answer and a negative 6 answer. If you're in Algebra 2, sometimes instead of finding the decimal, they have you simplify the radical. We're running out of time, so I don't think I'll show that process right now. But it is, instead of getting the decimal, you might have to do the simplifying process. So we square rooted. That was our 6th step, square root. Now we have...
I've got one question. So when sometimes when it'll ask me to find the decimal or find the square root and it ends up as a weird decimal, instead of just doing the regular equal sign, it'll have like a squiggly kind of equal sign. I don't know what the actual term for it is.
The approximate symbol. Technically, so sometimes I'm a little lazy. If I were the perfect mathematician, I would remember this every time. But you are correct. Technically, I should be using the approximate symbol because it's not exact anymore. There was a whole bunch more on that decimal that I just didn't write. So the approximate symbol is saying, we rounded here. And so you'll see it a lot. It's not super important to include in your answers, but that is very technically true.
Okay.
So we're almost done with this problem, then we'll take more questions. Sorry, completing the square is just a really long process. So since there are actually 2 versions, there's the positive 7.3 and the negative 7.3, we actually have to write this as 2 separate equations. If we're going to finish our solving process, we're going to take each possible answer. There was the positive 7.3 version, and then we can write a second equation with the negative 7.3 answer. So now these are basically 2 separate things that we're going to handle separately. How would I solve this equation? How can I get the 3 to the other side?
7 times 3.
We always want to focus on the math symbol that's there and pick the opposite. So right now the 3 is adding to the x, and we want to do the opposite of adding the 3.
So we're going to subtract.
Good. Subtraction is the opposite. So our first answer is 7.3, and we rounded, so I'm going to erase this and just do the 7.3 minus 3. So 4.3. And again, feel free to use calculators. It's hard to do decimals in your head. So on the second equation, it's actually the same opposite. We still minus 3, but since we start with a negative 7.3, the answer is going to come out different. 7.3 negative minus 3 is negative 10.3. And there's our 2 answers. So again, I know completing the square is kind of a long process. It's pretty confusing. You'll probably want to see it multiple times before you feel more comfortable with it. Okay, so more questions. Now it's just questions from your individual courses again.
So far, everything's been a little bit, been pretty clear.
You can do Monday.
I will have to leave you here very soon. Unfortunately, I have to clock in at security in about 20 minutes, 20 to 30. So unfortunately, yeah. Thank you. It was absolutely wonderful today. Definitely helped me solve the equation that I was stuck on. So,
good. Okay. And anytime you have questions, feel free to send a chat or send an email. These sessions are every week done by me. There's another math one, I think, on Tuesdays. It should be up on your dashboard. But yeah, you don't have to stay the whole time for sure. Everyone has their own schedule. So you can leave the meeting whenever you need to. Does anyone else have questions that is still going to be here for the last 10 minutes?
I will, because I'm still confused on the square root. Like I know how to get to the number, but I don't know how. I'm still confused on how we add it. Like I know we put from left to right on some of the questions, but I just get stuck when it comes to the negative. I don't know how to really break it down. And you just showed me like twice, but I'm still confused.
So just adding and subtracting negatives, or so like doing a problem like -5 plus 23?
Basically, like we did, okay, so we just did rows and columns. So we got the 3 times 3, but it was like, what was the negative?
It was a -1 times a 3.
Yeah, like -4x times, -4x minus 4. Like I know it's 16 because it's been to a positive, but I don't know. I just gotta study more because a negative times a negative is a positive.
Yes. Yep.
Okay. So if it's a negative and a positive, what would the outcome of that be?
A negative times a positive is a negative.
Okay. Okay. I just got to write that down so I can remember. Okay. Well, that's all I was asking.
Okay. So, and just to clarify a little bit, one of the big things that can mess people up with negatives and positives is that you have different rules for multiplying than you do for adding. When you're multiplying, the rules are positive times positive equals positive, or negative times negative equals positive.
Okay, that's what I was, okay, I just wrote that down. Yeah, that's a thoughtful, so now I can understand it better.
Okay.
So even when I'm multiplying positive, 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 negative times a negative is a positive. But when you're adding and subtracting, negative plus positive is a negative, and a negative plus a negative is a positive. Right?
So addition is a little bit different. So those are the multiplication rules. Addition rules, positive plus a positive is always positive. That's similar. Seems like the multiplication rule. But then it switches. Negative plus a negative is a negative still. So that's different. When you multiply, negative times negative is positive. When you add, a negative plus a negative is a negative. So that's where the confusion usually comes from.
Okay, I think I got it now.
Okay.
I think I got it now.
Okay.
Thank you.
Yep. Any other questions? We have about 5 more minutes. Or if you want to see anything again, we could greatest common factor again, or multiply matrices again. Anything you want to practice another time. Well, if I don't hear any questions, then I think we'll end for today. Thanks for coming. If you do want to ask me questions besides live session time, you can email me, you can send me chat messages, or if you're not my specific student, you can send emails and chat messages to your own teacher. But I'm happy to answer any question if you get stuck while you're working. So thanks for coming, and hopefully I'll see you guys next week.